Moving on to assemblies. So these are multi-body assemblies are quite or extremely similar to what you have already seen in SolidWorks assemblies. In place of mates, you now have joints, and both joints and mates, through some specification, restricts the motion between bodies, between two or multiple bodies. And then restriction is represented in mathematics through the restriction of motion between either through restriction of translation relative to one axis, one or multiple axis, or the restriction of rotation around one or multiple axis. And based on the combination of which axis you choose for restriction, translation, or rotation, multiple types of joints are available. And if you want additional information, we can look them up on the MathWorks help page. It's MathWorks documentation, but that isn't really necessary since the names of joints are imply what they really do or what kind of restriction they apply. And another note is that if you have used multiple versions of SolidWorks, let's say starting with 2008 or so, you may have seen that with each year they have increased the amount of mates that are available, and with each and nowadays compared to what they had in 2008 or so, in the 2008 versions or so, now they have some additional mates which go beyond what's offered by these primitive mates as well. And in a similar manner, solid Simscape multibody has been extending their primitive constraints as well. So the joints are the primitive constraints, and in addition to those, they have been extending bit by bit into the domains of gear, pulleys, and other types of constraints, which are kind of extended versions of the primitive ones. And I think they will keep increasing this year by year, and with each year, the library of advanced constraints will grow bigger and easier for us to model. The important thing for us is that at the moment we should know that every single mechanism existing in the world isn't necessarily modelable using Simscape multibody, or at least not. At least you have to spend some considerable time in developing the advanced mates or joints by yourself based on the primitives. So that's something I need you to know before jumping into make implementing a model for something that you see in the real life. You need to study whether this is doable or not. I won't say that nothing, there are few things which are impossible to do. I am not going to say that exactly, but I'll definitely say that some advanced joints need to be specified by yourself, since those kinds of joints aren't already available in multibody library. Okay, let's move on. So we'll begin developing our model in Simscape. We can either begin with what we had from lecture 6 and replace the ones we don't need anymore with what we plan on implementing. So instead of that, I have chosen today to build everything from scratch so that we may have some recap session as well. And I also want to highlight how easier it is for us to implement if we implement every single aspect of the model using Simscape blocks. So let's begin. So I open the canvas using sm new command. This will bring up a template with the composite blocks included and some other commonly used blocks available, and some tips. I'm removing these. I'll keep these things since we're definitely going to need them. First task of all is to save your file and give it a meaningful name and a version number. I'll give it simple example of a rod. Version is 1.0. It's now time for us to decompose our system once again. I hope you remember my advice or my guidelines that I have given you in previous lectures. Whenever we develop a system, the first thing we do is decompose it into subsystems, then the subsystems into subcomponents. Our simple system really doesn't have any complexity to which subsystem might be visible, but we can see the three components quite directly. So we have the rod, we have the revolute joint, and we have the motor, and perhaps a power supply as well, a 12 volt constant voltage power supply. So now we know that the motor can be directly imported through a Simscape block for a power magnet DC motor. I'll bring that in, keep it within the canvas, I won't make the connections yet. Apart from this, I have to bring in voltages and references as well. I'll complete the electrical side, but won't make any connection on the mechanical side just yet. So that with regards to one of the three components, two remaining are the revolute joint and the rod. We'll take a look at the rod now. So it is a solid body, and the tool available in Simscape multibody to develop solid bodies, especially rectangular ones, is something called a brick solid. So now this is used to describe to MathWorks a, a cuboidal solid geometry and mass distribution and inertia. Now if you want to know what kind of block that you'll need in order to specify a cylindrical body, bring up the help and navigate backwards, and you will see what kind of model that you will be needing. Under the bodies page, you will have multiple types of blocks which are available for bricks, cylindrical, ellipsoidal, so on and so forth. Go back to the slides. So I have suggested that you use a brick solid and a rigid transform. Still haven't told you what a rigid transform is. And I